Oh, well, you just have the link, but okay, cool. 535, encode and decode TinyURL. This is a companion problem to the system design problem. TinyURL is a URL shortening service where you enter a URL such as some URL and it returns a short URL like another short URL. Design encode and decode methods for the TinyURL service. There is no restriction on how your encode decode algorithm should work. You just need to ensure that URL can be encoded to a TinyURL and a TinyURL can be decoded into the original URL. Cool. Yeah, so there are definitely a lot of ways we can do this, right? Yeah, I wouldn't go that far, but we could work through it together. These are usually the first time I've seen these, but also, why does it have such a huge negative thing? Um, so I think the fun, interesting thing is usually these kind of problems have like an initialization. Oh, okay. So I think you could write a constructor just to be clear, so that you could kind of keep track, right? Um, and for that, then I would just keep track of n is. I mean, there are a lot of ways we can do it. It's just that technically, like it's like in real life, you would actually worry about like concurrency issues and like race conditions and stuff like this. Um, I don't know if that's part of this problem, to be honest, because well, I just don't know. But um, yeah, uh, does it have to be a tiny URL? Like, does it have to have this prefix? I mean, you could do it a number of ways as long as you kind of make it shorter. And I think just keeping things in a hash table or something is probably fine. I mean, I really don't know. Like, I think some of probably to your confusion and to my confusion right now is that there are a lot of ways you can solve this, and it'll be good-ish. It's just about different trade-offs, right? And the trade-offs are kind of the more interesting parts for system design specifically. But but for this, because this is like not like in an interview, this is quote unquote easier in the sense that like you could talk things through with your interviewer, but like, hey, I'm thinking of doing this. Do you think I'm thinking of, but it has these kind of drawbacks, but it's fast, etc. And then they'll be like, okay, but X, Y, and Z, like you want to design for X, Y, and Z, and then like so that kind of back and forth will allow you to kind of quote unquote read the interviewer's mind easier, but in an online judge kind of way. Like you know you don't necessarily know how they want to think about this per se. But yeah, I mean, base 64 encoding also works, right? Like it just has to be shorter, right? But I would say like, or is it base 64? Because I think this is actually base 36, right? Or sorry, 62? No, 26 times 2 plus 10, right? That's 62. So base 62. What is a hash table? I really can't tell. Trolling, but yeah, but I would just put things in the lookup table. And in this case, I'm actually going to use an array. Um, and then for each encode, we just for lookup dot append long URL. And then we just return. I don't know what we're supposed to return. Do we have to return like an actual, like something like that? Well, something like that, maybe. We don't actually even need to end here. And then on the decode, we just return something. Look up. Oh, well, I guess we have to pause this. Yeah, okay. I mean, I'm just gonna do something specific. Maybe I would have used regex if I wasn't lazy, but I don't know the constraint for this, so like, it may be that they give us invalid input. But yeah, I don't know what the one code one does actually. Yeah, is is it just like I really am confused, like what the problem is kind of doing? Um, Kind of. You could set it. So I mean, a hash table is just a dictionary, or the other way around, technically, or something like that. I'm just gonna submit because I really don't know what they expect. I may be wrong, just because this is a little bit of an ill-defined problem, so I'm really confused. Okay, but yeah, I mean, I think yeah. So hash. I don't know if you're familiar with dictionary, depending on what language you're familiar with, but it maps any key to a value. It doesn't have to be a numeric value, but it's just a key values data structure, and it's something that I definitely recommend reading up. I don't. I mean, I would say I've definitely gotten interview problems, or not problems even, just like verbal interview questioning of like, hey, what's a hash table? What are the properties of a hash table? What happens when this happens when you do a hash table? And so very stuff. If you do any sort of interview, you're going to face it at some level. Oh yeah, sure, hash code. I mean, you're right in that in Java, I think that's how it gets implemented. So and maybe even Python. Not think about it, but you are right. I mean, there's some internals to it, but yeah, because usually the key you just there is a function that converts any key into what you call it into sorry, a function that converts any key into a hash code, which is used as the hash table for the hash table to kind of do its internal things, though you don't need to think about it in theory as a black box. Yeah, I mean, I think just chaining and open indexing is already good enough. I think there are a couple of other ones like what's it called? Just using was it double hashing and but like I think these are just things that you could talk about and just knowing about them is probably good enough. You don't really have to kind of go about. I mean, except for the worst case, I think the chaining one is the one that people always talk about when you talk about worst case because in theory you could construct a case such that like it runs in linear time, so then like instead of all of one amortized if you're really like not careful about it. And fun fact is that very recently I actually discovered this issue in a competition where I was using C++. I was using unordered set, and it turns out that it timed out because the input had something that made it like degenerate to n square, where it should be if you yeah in the linked list essentially. So yeah, yeah, but you learn. So you live and you learn. But yeah, I don't know how to explain this problem. I mean, I think this is more of a better of a system design problem, really, because I think here what I did is very basic. And also, to be honest, this is essentially what I think Twitter actually does this similarly, but not. I mean, it's easy to say that they quote unquote just do this, but actually it's way harder because they implement this in a distributed manner. So like the counter, for example, they have to figure out how to do distributed counter, which is an easier thing to say than whatever. And then there's some math about converting that into a base 52 or maybe or 60, sorry, 62 or base 64 or base something URL, but and so forth. And but yeah, but conceptually it's about the same. Cool. I don't know. This is a little bit of a silly medium. Yeah. I think this is like, I don't know. But still, um, I don't know. I don't know if there's that much things to be learned from this problem. I think for an interview, like as I said, the system design is the one that comes up a lot for these kind of things, and then that's when you kind of go over the trade-offs and stuff like that, and that's the more relevant part. But for the coding part, like I don't know, it is not usually the important part to this question. Cool. Yeah, I mean, people could people can what was my time? I don't forget my I forget my percentile. Hey, look, so I mean, you sending me a link that's to a code that's slower than mine. So I'm just kidding a little bit. My running time is really fast on this one because I don't do anything. That's why I was confident knowing that my running time was going to beat a lot of people just because um, that link isn't even a link. But I was confident that no one else is going to be my running time, at least in Python, because um, I just use an array lookup. So it's even easier than a hash table. But uh, yeah, I mean, you could definitely do something like that. Uh, yeah, I mean, I don't know what to make of that. Like I said, there are a lot of ways to do this problem. Most of them are okay as long as you. I think this is just a poor problem in general. You will get asked that sort of things, but in system design and not in the coding portion. So I wouldn't really worry about that specifically. But if you could answer that, if you can answer that problem in a system design, then you shouldn't have any problem answering it in coding. So